We also have a LMS Python example, and we also use Iron Maiden Aces High. Here is.
We shall go on to the end. We shall fight in France. We shall fight on the seas and oceans.
We initialize here with zeros error or H coefficients, and we have zero starting values folder. Here we have prediction error and filter using the vector of the time reversed impulse response, and here is the update rule according to the definition we just mentioned before. Is the update rule here. So then we have the mean squared prediction error. It's calculated here, and we can listen to the error.
We shall go on to the end. We shall fight in France. We shall fight on the seas and oceans.
And here's the comparison plot of the original signal to the prediction error. No signal in blue, the prediction in red. And we observe that the prediction error is bigger than in the LPC case, but we also don't need to transmit the prediction coefficients as side information. So the comparison plot of the original to the prediction error can be seen here. But for the decoder, we get the reconstruction. That's what we're in here, decoder. But we have some problem. In the decoder, we need to pay attention to the sensitivity. So when we start here, there's the update rule. We initialize with zeros, but we find some minus infinity here, very big values. So this is the reconstructed signal. So in the decoder, the sensitivity of the decoder for transmission errors, and the code for the decoder, the LMS update for the predictor H. We need its rec instead of X, since X is not available in the decoder. And the slightest computation errors, for instance rounding errors, are sufficient to make the decoder diverge and stop working after a few syllables of the speech. We see that the computed prediction coefficients differ in the last digits between encoder and decoder, which is enough for increasing divergence between encoder and decoder until the decoded signal explodes, becomes huge from instability. So this shows that the LMS is very sensitive to transmission errors. To avoid these, the computation errors, we need to include quantization in the process.